Today, we are going to talk about using TypeSpec to create declarative agents for Microsoft 365 Copilot. This is a demo which is part of the Copilot Developer Camp labs and demos. The Copilot Developer Camp is a set of videos and hands-on labs that you can use to learn how to extend Microsoft 365 Copilot. And you can do that as a maker or as a professional developer, depending on what your profile is. There are multiple pathways. You can find it at akms/copilot.camp. And just to give you an idea, if you are a maker, you can go through multiple pathways to build agents with Agent Builder, with Copilot Studio, or with SharePoint agents. Or if you are a coder, like we are going to be today in this demo, you can create declarative agents if you want to rely on the out-of-the-box foundational model and orchestrator of Microsoft 365 Copilot, or you can create custom engine agents and agents for teams if you want to use your own foundational model and orchestrator. And this is what you can learn going through all of the pathways available in Copilot.camp. Today, we want to focus on the declarative agents. So we want to rely on TypeSpec, and we want to learn what TypeSpec is and how we can use it to create a declarative agent. And first of all, let me clarify what a declarative agent is. As I said before, when you create an agent to extend Microsoft 365 Copilot and you rely on the foundational model and the orchestrator provided out of the box by Microsoft 365 Copilot, you create what is called a declarative agent, which can have a custom set of knowledge bases and a custom set of skills like actions, triggers, or other custom stuff that you can trigger inside your agent. And the user experience of those declarative agents will be the user experience, the out-of-the-box user experience of Microsoft 365 Copilot Chat. They are defined as declarative agents because when you create them, when you define them, you basically declare the functionalities and the capabilities that you want to have in those agents, and you don't necessarily write actual code. Or actually, it depends. Let me explain you why. Because Microsoft introduced recently the TypeSpec language, which is a language designed for designing and defining APIs in a lightweight manner. And it has been inspired by TypeScript. So you will see in the upcoming demos that the syntax looks almost like the syntax of TypeScript. It is a structured language and a type-safe language. So you can use this language in Visual Studio Code or in Visual Studio, and you can use it to generate, starting from the TypeScript syntax, the TypeSpec syntax, sorry, you can easily generate OpenAPI specifications, JSON schemas, and generally speaking, definitions for your own APIs. Now, from the declarative agents point of view, we can use TypeSpec to easily define agents, declarative agents, which can also consume external API plugins. And you can have an abstraction from the JSON file that we used to create declarative agents in the past. And you can simply write code, which can even be checked from a syntax point of view to avoid any error or any issue. You can validate the definition of your API when you define them with TypeSpec. And you can have IntelliSense in Visual Studio Code, for example, when you write those definitions of agents. Last but not least, when you use TypeSpec, you can also rely on the dev proxy project, and you can generate the TypeSpec specification files on the fly based on the HTTP network traffic that you make go through the dev proxy tool. So let me switch to the actual demo environment, and let me show you how a TypeSpec declarative agent is defined. So first of all, I will go to my Visual Studio Code. So let me open it and share it with you on my screen. And here we are. And in Visual Studio Code, whenever you want to create a new declarative agent, you can rely on the Microsoft 365 Agents Toolkit, which is available under this icon and that you can find under the extensions for Visual Studio Code, for example. If you select the M365 Agents Toolkit, you can then select to create a new agent or application. And by doing that, you can choose to create a declarative agent, which is the focus of today's demo. When you select to create a declarative agent, you have multiple options. The one I'm interested in right now is the one to start with a TypeSpec for Microsoft 365 Copilot. If you will select this option, you will need then to provide a folder where you want to store your your scaffolded declarative agent solution. Let's use the default one. And you will need to provide a name. Now, what I'm showing you, what I'm going to show you is a demo that you will find also available, as I said, in one of the labs of the Copilot Dev Camp, and which is called the Repair Service Agent. Right now, I'm just going to create a random declarative agent for the sake of showing you what happens when you use the toolkit. And then we will switch to the actual demo that you can implement by yourself, following the instructions, step-by-step instructions of the lab. So, for example, I can define a community declarative agent solution just for the sake of it. This will be the name of the solution that will be scaffolded by the toolkit. And as you can see here, let me maximize the screen. You get back a bunch of information about the generated project with instruction about what you should do to rely on this project. But what I'm interested in, and let me zoom in a little bit more, is that you will get a couple of .tsp files, which are files based on TypeSpec syntax. And as you can see in these files, we have syntax that looks almost like the TypeScript syntax. As you can see, we have the import of modules, we have the using of namespaces, we have some decorators to define some specific attributes for my agent. And here you can see that we can define the title and the description of the agent that we want to define. We can specify a set of instructions, which will be what we usually call the system prompt of the agent you are going to create. You can uncomment and define conversation starters for your agent, which will look like the boxes with suggestions for the user in the native experience of Microsoft 365 Copilot. And then you can define all of the capabilities that you want to make available in the agent, like, for example, the capability to use specific REST APIs, plugins. And that's why we also have an actions.tsp file, which can be used to define those API plugins. And in the action.tsp file, you can again rely on the syntax of TypeSpec to define, for example, that we have a specific namespace where we want to have some metadata for the API we are going to connect to plug into the declarative agent with a specific URL that will be the URL of the API that we want to consume, as well as the definition of all of the operations that we want to consume in that target API. As you can see right now in the scaffolded solution that you get when you select in the toolkit to create a fresh new declarative agent, you find a sample that simply relies on the APIs, REST APIs of GitHub to search for issues in a specific GitHub repository. Now, let's switch to the actual lab that you can build with the Copilot Dev Camp. And in order to do that, let me switch to another Visual Studio Code instance that I have right here. And so this is my service, my declarative agent, the repair service agent. In this one, we want to have an hypothetical repair service where we can work with items like replacement parts and workers in the repair service, and we can create new requests to repair stuff and to assign those repair requests to specific users. Just to give you an idea, let me actually run the agent first, and then let me show you how it is implemented. So here I am in the Copilot Chat, Microsoft 365 Copilot Chat, and this is my repair service agent. And I can do stuff like, for example, listing all of the repairs that I'm running right now with my repair service. By doing that, I will be able to invoke for example, an external API, which will give me back information about all of the repairs that I have listed in my system. So I can allow Copilot and the agent to consume the external API. And as you will see near the end of this demo, under the cover of this request, there will be a REST request to an external API, which will retrieve a list of repairs with detailed information, pictures of the repairs, and stuff like that. Takes a little while because it is actually consuming a real API, which is running on Azure right now. But soon you will be able to see the output. We should be almost there. And we should be able to see the list of our repairs, hopefully soon. Let's see. Okay, here we are. So we have an oil change, a brake repairs, and stuff like that. And also soon we will see the pictures of all of these repairs so that we can have additional information and graphical information about all of the repairs that we have in the list. So this is the idea of this sample explanatory agent. And you can find it if you go to AKMS/Copilot Dev Camp under the extend pathway, and you will find it here in the lab E1, which is the build a detailed declarative agent using TypeSpec. And here you can find step-by-step the instruction created by my colleague Rabia that you can use to build exactly the same agent. Now, let's dig into the actual agent in Visual Studio Code. So as before, we have a main.tsp file. In this one, we have the title and the description. We have the instructions, and here you can see this is a much more detailed set of instructions, which will tell the agent how it should behave when interacting with the user. So you will assist the user in finding car repair records and so on and so forth. We provide the guidelines, and we give all of the instructions, the system instructions, to the agent itself. We have a couple of conversation starters, which are those that you were able to see in the UI of the declarative agent when you start a new conversation, these two items. Then we have the definition of the repair service agent. And in there, we have the reference to a capability available in declarative agents, which allows us to work with the code interpreter, which is a capability that allows you to generate charts and diagrams and to get the source code in Python to generate those charts and diagrams based on the data that you have available as the knowledge base for your agent. Plus, we have a set of APIs to list, create, update, or delete specific repair records. So in the action.tsp file, we have the definition of those actions. And again, we have a namespace, which has been enriched with a set of decorators to specify that we are defining a service with a specific server URL and with a specific set of metadata for the action, which is actually defined right here. Then we have, and this is the URL of the service, which is, as you can see, running on Azure. And then we define every single operation. Like, for example, if we want to get the list of repairs, we can just use the TypeSpec syntax to declare that we have an operation with name list repairs, which will get in the query string eventually, which with an optional input argument, the assignee of those repairs. And then we can see that we have a post request operation to create a new repair. And in the body, we will get a repair object, which means that we have a definition of the model for the repair object. So we have actually the model that defines how a repair looks like with all of the required or optional fields that make up the actual content of a repair. A repair that can also be updated with a patch HTTP request to the REST API, or can be deleted with a delete HTTP method, again, providing the body of the repair that we want to delete or to update or to create. So that, for example, when, again, we use the agent, we can say, create a new repair to replace with the actual content of the car repair. So it could be, for example, the rear camera, and assign it to me. And by assigning this item to myself, I will then be able to say, list all of my repairs and get it back. Now, since I'm posting some data over the HTTP channel to the target REST API, I need to confirm as an end user that I want to do that for security reasons. And by doing that, I will be able to create a new item in the repair service and to target myself as the assigned person to repair this item. And then I can say, for example, list all my repairs, and I will be able to see that the item, the record that I just created, has been assigned to myself. And again, I need to consent to allow the consumption of the external API to get back the information I'm looking for. And as you can see, I can get the item that I just created, including an hypothetical picture that I can use to show additional information about the repair. Okay, so this is really cool because we can simply work with a code-based interface. We can write our code in TypeSpec using IntelliSense, and we can define a declarative agent and all of the APIs plugin connected to the declarative agent simply using a code-based model. Just to give an idea of what's happening under the cover, let me enable the developer mode in Copilot. And by doing that, let me list again all of my repairs. For example, list all my repairs. By doing that, now that the developer mode has been enabled, I will be able to show you, once I will allow this request to go through the wire, that we have got behind the scenes the orchestrator of Copilot choosing what is the right flow to use to give me the answer. Actually, let me refresh the request and let me go through one more time because I don't see the actual debug information. So let me try again. Sorry about that. Hopefully it will show up. And when we list all of the repairs, for example, you should be able to get the debug information. And if not, you will need to trust me because you can always trust Paolo. And let's see if it will work. And I will be able to show you the debug information at the end of the request. And unfortunately, today, the debug information are not willing to work. And so I'm sorry about that, but I was not able to show you that actually when the debug information are enabled and visible, you can get the reasoning model behind the scene. You can see what are the actual operations available and what is the operation that the agent selected to run through the orchestrator of Copilot. And then you can also dig into the request and response at the wire level. So you can see the request, HTTP request, and you can see the JSON response that you get as the output from the REST API to do better investigation of what's going on when you consume an external API. So if you want to go through the same flow, you can simply go, as I said, to the Copilot Camp, go to the extend pathway, and select the E1 lab, and step by step, you can create exactly the same declarative agent using TypeSpec and being able to debug in the Copilot interface the low-level conversation on the wire with the external REST API. That said, back to you, Paul, and thank you for watching this demo.